Each month, the manager of a large store records the number C of customers who visit the store and the amount H pounds spent on heating during that month. The manager wants to test whether there's linear correlation between C and H. Randomly chosen year, value of Pearson's product moment correlation coefficient between C and H was minus 0.798 for 3 sig figs. Using the table below, carry out the test at the 1% significance level. So H naught. Now this is actually known as R. R equals minus 0.798. But we've actually got negative correlation, but what we're trying to find out is if there's actually going to be a negative correlation, or in fact any correlation. This is a two-tailed test. Is there any correlation in the, not just in this sample year, but in the whole kind of, in general, basically? So H naught is at rho, because that is actually the problem correlation coefficient for the population, like all of the data. So rho is equal to 0, and then H1, because we're just testing whether there's linear correlation, not positive or negative, then H0 is that rho is not equal to 0. So this is two-tailed. We've got our value of minus 0.798, just need to find the critical value. So it's talking about across a year, and therefore it's every month, so it's going to be 12 months. We're going to be looking along this row here. A little bit of time to like figure that out, but that's all it could possibly be. And then we're dealing with two-tailed, so I'm looking along these values and I want 1%. So it's going to be down here, therefore going to be this value here. I just note that although positive values are given, it actually implies that it's plus or minus 0.7079. So those are our two critical values for this two-tailed test. At this point, I quite like to draw, I'm going to draw up here, a little continuum. We've got minus 1, 0, and 1. And I've got my two critical values up here, 0.7079, and then here, minus 0.7079. So the critical region is here and here. And then for ours, we've got minus 0.798. So we can see I can just creep it inside. It's lower than minus 0.7079. And that's what I need to know. So I've got, so I write down minus 0.798 is less than minus 0.7079. Therefore, I will reject H naught. We're in the critical region. There is sufficient evidence to conclude that there is linear correlation. You could say between C and H. Yeah, I will say that between C and H at the 1% level. One thing I didn't do here, and I forgot to do it myself in the actual paper, is we really should define what, I did say out loud, but let's just write it down. Say what rho is. Rho equals correlation coefficient for the population. On to B, describe briefly two main features of a scatter diagram that could be drawn to illustrate the values of C and H for this year. There is no need to draw a diagram. Now I got to say, when I read this, I completely misinterpreted it. I just thought it was saying, what would you add to your scatter diagram when you draw it? So I went with you plot your points and align the best fit. It's just completely wrong. What this is actually sort of getting at is what would the scatter diagram actually look like? And it's all about the correlation coefficient. So because it's quite close to -1, then a feature is that the points are going to be fairly like close to a straight line. And then because it's negative, it's going to have a negative gradient. Okay, so that is what that was after. The manager then makes the following statement. The value of R shows that when we spend more on heating, fewer customers visit the store, so we should spend less on heating. Comment briefly on this statement, making reference to the context. So just because there is correlation doesn't mean that one actually impacts on the other. That's the key thing to take out of this. And the phrase is that correlation does not imply causation. So I wrote, whilst there is correlation, increased heating may not lead to fewer customers. What I didn't do and was expected was that you give a reason why what actually they could have depended on instead. So a third factor they were after, such as time of year, temperature, or weather. Okay, so I think next time I see one of these, I'll make sure I do that because I didn't do that here. Um, yeah, so reference when it says context, it was looking for like a reason why it might, why there might not be causation. Finally, give a statement about a probability. That threw me off a little bit to start with. A probability to explain the meaning of the value 0.7155 in the table below. So normally when you're doing hypotheses tests on this product movement correlation coefficient, you're doing exactly what we did in part A. You've got a value for the correlation coefficient and you compare it with the critical value. And we're told the significance level. But this question is really getting at what does the significance level represent? And it's, if you think back to say binomial, when you have a 5% chance, a 5% significance level, like that's your critical region. And if you're in the critical region, there's like a 5% chance you could be in it, that you could actually incorrectly reject H naught. It's that kind of thing. So here, it wants something along, well, this is what I wrote. I wrote 0.7155 is the critical value at the 1% level when conducting a one-tailed hypothesis test with a sample of 10. Okay, so I referenced the 10 and the fact there was 1%. Of course, it could be 2% two-tailed as well. I said there is then a 1% chance of not having correlation in the population if the product moment correlation coefficient is lower than minus 0.7155. So remember, we would reject H naught if we got, say, a lower correlation coefficient, but it doesn't mean it's not guaranteed, remember, because this is at the 1% level, there's still some doubt. So that's what it kind of wanted us to refer to. I'll just write down what the mark scheme says. So if no linear correlation if no linear correlation in the population, then for a sample of 10 pairs, the probability that R is greater than 0.7155 is 0.01. So that would be that's the chance of us saying, of rejecting H0 when actually, there was no correlation overall. Or you could refer to the two-tailed test here. So just, you have to roll with it and decide whether you've done enough if you have tried this question. But it's just hitting that 1%, like talking about the 1%, what does it actually mean? And I'm just going to say it in words again, like what I said. So I said, like, there's a 1% chance of us going into the critical region when actually H0 was in fact true overall, i.e. that there's no linear correlation. Maybe like this is what it's really getting at the heart of it. So maybe you have like loads of points like this with no correlation whatsoever. But if you're randomly selecting some, maybe you just select these. Now, obviously, this is just an example. This is only 3, so this is not very good. But it would look like there's really great negative correlation when there's not. So that's what the hypothesis test is getting at, and that is why the values are what they are. So as you take more in your sample, you need less kind of correlation from your sample to be able to get enough evidence to show that there's correlation in the population. Okay, hope that makes sense.